Today, I want to explain the internet is not a weightless cloud. In reality, it is a massive physical infrastructure supported by hardware, cables, data center, electricity, and cooling systems. When we send a message, stream video, or use online service, the data travels through routers, switches, and gateways. These devices have direct information to the right place. Most global internet traffic also depends on submarine fiber optic cables, not satellite. These cables lie deep on the ocean and connect continents around the world, allowing huge amounts of data to move at near light speed. And finally, cloud service rely on large data centers filled with the servers. These servers store, process, and deliver the data we use every day. So the internet may feel invisible, but behind its very real physical system made of cables, servers, electricity, and human engineering.
I have learned a lot during this semester and even built my own websites using the new framework and programming language for our family business. This was not possible for me before since it used to take a couple of months to master a framework and language, but now it's much easier using command line tools such as Cloud Code. We also learned from a front engineer from computer science department regarding the building blocks of Frontend 101, which enable us to generate more sophisticated and thoughtful architecture. Following, I'd like to introduce two topics that I resonate with the most. First, TypeScript over JavaScript. At first, I thought typing everything was just extra work, but once I started handling payment, payload, and order data in my project, I finally realized that JavaScript would have let silence bugs slip into production, a wrong field name, a missing property, and the payment failed without warning. TypeScript caught this at compile time, so for me, it's not just a language choice, it's a safer choice that let me refactor fearlessly. In the future, this will be essential when I work on larger teams when one small bug can break trust with real users. Second, React with Next.js. Instead of vanilla JavaScript or plain React, Next.js gives me server-side rendering, file-based routing, and building API routes out of box. With vanilla React, I would have spent days writing up routing and SEO myself. This taught me that choosing the right framework isn't about just being trendy. It's about focusing my energy on real products. Going forward, this mindset will help me evaluate any tool by asking, what does this free me from?
Before, when I built websites, most of them were relatively simple and independent systems. Usually the structure was just a user, a website, and a database. But after learning modern web development, I realized websites today are very different. Modern web applications often connect with multiple external services through APIs such as Google Login, payment system, cloud service, and database. API allow different platforms and services to communicate with each other efficiently. They help developers integrate many useful functions without building everything from scratch. Because of API, application can exchange information in real time, improving both functionality and user experience. I also learned that modern frameworks and connecting systems make applications more scalable and flexible. Web development today is no longer only about building web pages, but also about connecting systems together. Overall, this semester changed how I understand modern websites. They are no longer isolated systems, but part of a connecting ecosystems.
Today, I want to share my learning reflections on modern front-end engineering and web architecture. The Internet evolved through Web 1.0, 2.0, and 3.0, defined by their changing features over time. Understanding these progressions helps us better connect platforms and improve our business services. Tracking these functional shifts allows us to align technical trends directly with outward-facing business goals. The Internet isn't just a cloud, it's a massive physical machine of cables and data centers. Knowing how this hardware guarantees 99% uptime helps us accurately plan system architectures for high-traffic campaigns. In our project, using TypeScript was a game changer. It caught payment and order errors at compile time, directly preventing checkout failures and customer complaints. It's a crucial safety net. By removing this runtime risk, we make consumer trust from simple word of mouth to active recommendations. Choosing Next saves us massive setup time with its building routine. A good framework frees developers from tedious configurations, allowing us to focus entirely on outward-facing product features that generate real revenue. This shifting of energy ensures that our technical executions directly serve the primary goal of helping the company earn more. And this is our presentation. Thank you.